Hi everyone. Today I want to discuss about how to draw a Lewis structure. It is very important to understand for inorganic chemistry and also organic chemistry, and I will explain today very simplest method to draw any molecule in the inorganic or inorganic with the four step very easiest. Sometimes one more extra step required for organic molecule also, inorganic molecule also, that is a one extra, totally five step. In this five step you will understand very clearly to draw a Lewis structure. So the first one, they will give a molecular formula. From the molecular formula, we have to place the atom relative to each other. In that, what you have to do? Place atom with the lowest electronegative in the center. Otherwise, lower group number at the center. That will require more electron to attain the octet. Second one, calculate the sum of valence electron. For that, what you have to do in step 2, add a group numbers. It's nothing but valency electron. This is one. In this, add or subtract for electron for ion. Add electron for negatively charged species. Subtract electron for positively charged species. If neutral is there, only valence electron. If charged species is there, extra, add electron for negative and subtract electron for positive ion. That is, you have to remember. Step 3, remaining valence electron when you draw the structure. So how to calculate this remaining valence electron? Draw single bond and subtract 2 electron for each bond. So generally you will not understand this sentence. I will explain with the example. For example, total 10 electron, sum of total valence electron 10 consider for example, then it form 3 bonds. Any element form for example 3 bond. So each bond how many? 2 electron. 3 into 2 how much? 6. Then how many valence electrons are left? 4. So draw a single bond and subtract the 2 electron for each one, then you will get the remaining. It means 3 into 2, 6 electrons are utilized for bond formation and 4 electrons are left, mean 2 lone pairs are left. Step 4. Then the final one is what is that? Lewis structure with the single bonds only. Distribute the remaining electron, that is actually, so that each atom has a total 8 electron. In case hydrogen is there, that is a 2 electron. This is for single bonded total 4 steps. That's why a species with the single bonds only. Then next one, species with the multiple bonds sometime. Central atom lacks octet. It means when it is deficient to get the octet. After 4 steps, then you will get the 5th step. In this Lewis structure with the multiple bond, how you will get? Move one lone pair of electron to make the bonding electron pair. So one of the lone pair converted into bond pair, then multiple bond, that may be double bond or triple bond form. So now these are just rules. Remember, with 111 rule we will discuss a clear example now, then you will understand. So the first one, molecule with the single bond. This is called single bond. First one step. Step 1. Place the atom relative to each other. Rule 1, what is it? Place the atom relative to each other. In that, place the atom with the lower group number in the center. Nothing but lower electronegative. Lower group number, generally it has a lower electronegative. For example, carbon, nitrogen, oxygen, fluorine. In case carbon is a lower electronegative. In case nitrogen is a lower electronegative compared with the oxygen and fluorine. So now I am taking one example. NF3. Another example is BF4 minus. In this one, this nitrogen is the lower electronegative and this is called higher electronegative. So now in case you want, their electronegativity is nearly 3 and this is called 4 for fluorine. Boron electronegativity is nearly 2 and fluorine electronegativity is 4. So according to this, central atom here in NF3 is nitrogen and surrounding atoms are fluorine, fluorine, fluorine. Similarly, in BF4 minus, boron atom at the center lower electronegative, surrounding atom is fluorine, 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 fluorine. Like this, we can represent relative to each other. Then you may get one doubt also. If the atoms have the same group, like this, in SO3, place the atom with the higher period number at the center. In center. So now sulfur at the center, oxygen, oxygen, oxygen. These are placed at the center. When same groups it is there. In period, we can easily understand left side element is the lower electronegative, right side electron is the more electronegative element. In case group, then down element has a lower electronegativity, top element has a higher electronegativity. Then step 2. In step 2, determine the total number of valency electron. For example, NF3, now BF4 minus. In this, determine the total number of valence electron mean nitrogen atomic number 7, 1s2, 2s2, 2p3. So this is called valence electron. These are valence electron mean 2 plus 3. For 1 nitrogen, 5 valency electron. Similarly, fluorine atomic number 9. Then we can write 1s2, 2s2, 2p5. So here these are called valence electron. Then 2 plus 5, that is a 7. So 7 valency electron. Now 1 nitrogen, that is 1 into 5, that is called 5 valence electron, and 3 fluorine, that equal to 3 into 7, that is called 21. Then total, this is called 5 plus 1, 6, 26 valence electron. Similarly, boron atomic number 5, 1s2, 2s2, 2p1. This is a valence electron. Total valency electrons, that is 2 plus 1, that is called 3 electrons. So 1 boron we have. So 1 into 3 valence electron, therefore 3, and we have 4 fluorine, that is called 4 into each one has a 7, because already I shown here this is called 7 valency electrons. Therefore we can say this is 28 electron and one negative charge, therefore we have to add electron. Therefore this is 1 into 1, that is called 1. Totally This is 32 valency electron. So keep in mind here 26 is there, here 32 valence electron is there. Now step 3. Draw a single bond from each surrounding atom to the central atom and subtract 2 electrons for each bond from the total number of valence electron to find the number of electron remaining. Now carefully you have to listen. First one, nitrogen, N, and we can say these are fluorine, fluorine, fluorine. So for each one bond. I am drawing one bond, one bond, one bond. So total how many electrons are there? 26 electron. Out of 26 minus for each bond, subtract the 2 electron for each bond. Therefore, how many bonds are there? 1, 2, 3. 3 into 2, 6 electron I am subtracting. Therefore, I am getting how many electrons subtracting? 6 electron. Then how many electrons I will get total remaining? 20 valence electron remain. These many are remain. Next one, here boron, then I have fluorine, 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 fluorine. Then for each one bond, second bond, third bond, fourth bond. Total 4 bonds are present. Total valence electron how much? Total number of valence electrons are 32. Then minus how many electron I have? Total 1, 2, 3, 4. 4 into 2, 8 electron I have to remove that. Therefore, 8 electron. Then how many are left now? 24 electrons are left. So this is called remain electron. How many are remain now? 24. Now step 4. Distribute the remaining electron in pairs so that each atom ends up with 8 electron or 2 electron for hydrogen. For first place lone pairs on the surrounding atom, and that is called more electronegative atoms to give each an octet. If any electron remain, place them around the central atom. So what are the remaining electrons are there? So first you have to place on the surrounding atom, then you any left electrons there that you have to place on the central atom, then each one get the octet. Now we have N F3. This is called NF3. Out of 26, totally 6 electron removed, then 20 left. So among the 21, we have to get each atom. How many atoms electrons are left? 20. That I am distributing now. Each one should get the octet. So here already 2 electrons are present. That is called one bond. Then this is 3, 4, 5, 6. These are 6. 6 plus these 2, total 8. This is 2. So 8 are there. Then 1, 2, 3. Total 3 lone pairs. Then here also 1, 2, 3. 3 lone pairs and each one bond. Then each one getting how much? Total 8 electron surrounding atom. Now out of this one, total 3 into 3. So total 18 electron. Because here if you are confusing me, I will count all this. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Out of 20, how many electrons are already utilized? 18 utilized. Then how much left? 2 electrons are left. These 2 electrons are one pair. So remaining electron placed on the which one? Surrounding atom. So now I am placed, central atom. So this is a central atom. then each one getting the octet. Now check around the this nitrogen, 1 2 3 3 into 2 6 7 8 8 all are utilized. So now we are going to check the for BF4 molecule, BF4 minus molecule. In this we'll take boron central atom, 1 fluorine, second fluorine, third fluorine, fourth fluorine. So now out of that 32 valence electron, 32 minus how much, 8, then we got the 24 electrons are remain. So each one should get the octet. So according to this one, I am taking this 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 1, 2. 3 lone pairs. 1, 2, 1, 2, 1, 2, 1, 2, 1. Like this. So now total 24 are left. Among that, how many are utilized? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 are utilized. So all are utilized here now. So here total 26 electron utilized. Here 32 electrons are utilized. Complete utilized here. Therefore, each atoms are getting octet. Now, around this central atom, 4 bonds are there. 1, 2, 3, 4. 4 into 2, 8 electron. So, each atom got the 8 electron. That is octet complete. Therefore, they are stable. BF4 minus is a polyatomic ion. We also take the charge into account as described in the step 2 and put the structure in square bracket with the ion charge as a superscript. It means uppercase outside the bracket. That is can be represented like this: B F F F F, and whole square bracket and put the charge on the superscript. This is one negative charge. This is a complete representation for BF4 minus. In case NF3 is there, this is for BF4 minus molecule. For NH3, NF3 molecule, just this can be represented the one lone pair and fluorine, fluorine, fluorine. This is structure for NF3. But keep in mind, since Lewis structure do not indicate the shape, so in the NF3, this one I wrote in the first one case is like this: F, F, F. So these bonds are perpendicular to each other. Now I can write like this also: F, F, F. All are in the one side only. So it do not indicate the shape of the molecule, only to draw the structure, that much only. Now in BF4, 1, 2, 3, 4. Otherwise, I can write this is like this also: B, F, 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 whole minus. So it do not describe the shape of the molecule. It explains the how to draw a Lewis structure between the central atom and surrounding atom, that much only. Using these 4 steps, you can write a Lewis structure for any singly bonded species with the central atom carbon, nitrogen or oxygen atom, as well as some species with the central atom from higher periods, that is called third, fourth, fifth period, nearly all their compound. But you have to carefully remember this one, very important. So this concept is very much important. We have to remember hydrogen atoms form one bond, carbon atoms form four bond, nitrogen atom form three bond, oxygen atom forms two bond, surrounding halogen atom form one bond, fluorine always as a surrounding atom because it forms only one bond. Keep in mind these are very important to draw the Lewis structure. The next one, molecule with the multiple bonds. Step 5. After the 4 step, the next one if it is required, that is a step 5. If a central atom does not end up with an octet, form one or more multiple bonds. How it form more multiple bonds? Listen now. Change a lone pair on a surrounding atom into another bonding pair to the central atom, thus forming a double bond. This may be done again if necessary to form a triple bond or to form another double bond. So when it is required, it may form two double bonds or one triple bond, or any according to the requirement it form the multiple bond. So now we'll try one example. Let's draw the a Lewis structure for the oxygen molecule. So now I am drawing, this is a O2 molecule. How to draw according to these 4 points. Next one including fifth point. Step 1. Place the atoms relative to each other. How to place now relative to each other, meaning we know we can place this is oxygen, this is oxygen. This is one possibility. Then step 2, find the sum of valence electron. Oxygen belongs to 6th A group, therefore I am counting now. This is oxygen atomic number 8, 1s2, 2s2, 2p4. Then these are called valence electron. Valency electrons are 2 plus 4. These are 2, these are 4, then total 6. We have the 2 oxygen atom, therefore 2 into 6, that is called 12 valency electron. So total valence electron this is. Next, step 3. Draw single bond and subtract 2 electron for each bonds. So now already we know these are the relative to each other. Then now I drawn a single bond between the two atoms. Then we have to subtract the 2 electron. Total 12 electron minus 1 bond. So 1 bond means 2 electron. Therefore I am subtracting the 2 electrons. Then total remaining electrons are 10 electrons remain. Now, step 4. Add the remaining 10 electron in pairs. There are enough electron for the oxygen atom on the left to get 3 pairs to complete its octet. Now, according to that rule, oxygen, oxygen, bond. So, for oxygen to get octet already, this is a 2 electrons. Therefore, I am drawing now number of pairs of electrons 1, 2, 3. 3 into 2, 6, 6 plus this bond 2 electron, 8 electron. Out of 10 remain electron, 10 minus how many electrons? 6 gone. Then how many are left? 4 electrons are left. 4 electron meaning I will place these are on the next oxygen 2. But right side oxygen atom has 2 plus this 2, 4 plus this 2, 6 valence electrons. It means not complete octet. Therefore, here that is given. But oxygen atom in the right only gets 2 pairs electron and thus does not have an octet. Step 5 is necessary now. Up to 4 step we utilize it, then 5th step we have to utilize now. Step 5. Change a lone pair on the left oxygen atom to another bonding pair between the two oxygen atoms so that each oxygen atom in the molecule has an octet. So now I am drawing that oxygen with one bond and pair of electrons 1, 2. Otherwise, consider like this is one pair, this is a second pair, this is a one, and this is called 1, 2. Then this pair I am converting into the bond pair. Then totally oxygen is a bond pair. Then we have this is a lone pair, and this is also lone pair. Then this one is converted as a bond pair, so I will convert as another bond. This is a multiple bond between the two oxygen atom. Now count 1, 2, 3, 4, 5, 6, 7, 8. Octet complete for the left side. So 1, 2, 3, 4, 5, 6, 7, 8. Right side atom also got the octet. Like this, each atom will get the octet. You can apply this rule for organic or inorganic molecule very effectively. And this is a very simplest method I given with the very beautiful example. So I hope you understood and apply for the all molecule you will get. If case positive charge is there, that time we have to remove electron according to number of positive charge. One positive mean one electron, two positive mean two electron remove. For example, negative mean I show now one electron added. In case 2 minus is SO4, 2 minus 2 electron add, 3 minus 3 electron add. Like this we can add or remove according to their charge. If neutral is there, no need to add, only valence electron utilize. I hope you understood well. Thank you.